All right, 1-4, we are going to solve some inequalities. All right, so just like with the equations we had, the solutions of an inequality are the numbers that make inequalities true. And just as a quick reminder, our inequalities are less than, red amount, less than, greater than, and then we've got less than or equal to and greater than or equal to. So this is less than or equal to, and this is greater than or equal to. And while I'm writing that, there's one more inequality. See if you can come up with that one. If you said not equal to, you've got it. So there are 5 inequalities that we use in algebra. Okay? All right, so let me erase this, get it out of the way, and we can take a look at this. For instance, if we have this inequality, negative 2x is equal to 10, there's just one answer to that. The answer to that is negative 5, right? If we have negative 2x equals 10, we divide it by 2, and by negative 2, and we get x equals negative 5. But if we switched it around and we had an inequality saying negative 2x is all the numbers that are smaller than 10, then when we divide, we're going to get x is, and remember, so still negative 5, if you remember from algebra, for inequalities, if you divide by a negative, we're going to switch our inequality around. So it becomes x is greater than negative 5. Let's take a look at this number line up here. Notice right here the open circle on 5. Okay, that's just the greater than. If I switch this up to be greater than or equal to, we're going to fill that circle in. Okay? All right. So let's take a look at some of our properties here. Transitive, we've seen this before. All right, if A is smaller than B and B is smaller than C, then you know A has to be smaller than C, right? If A is over here, which is smaller than B, and if B is smaller than C, then you know that A has to be smaller than C, okay? All right. Addition property, if we add something to two numbers, the relationship still is the same. So if A is smaller than B to start with, if I add a number, A is still smaller than B. Same thing for subtracting. It goes both ways. All right, and then multiplying. If I multiply by a positive number, that's what this is saying right here. If I multiply by a positive, then our relationship is going to stay the same. If A starts smaller, it's going to stay smaller. But if I start to multiply by a negative number, something less than 0, then our original relationship is going to switch around. All right, we just talked about that on the last slide when we divided by a negative. So we're dividing as well. All right, so notice that the inequality is reversed when we divide or multiply by a negative. All right, that's what this slide is saying. All right, so let's try some of these here. 3x minus 12 is less than 3. We're going to solve it, and then we're going to graph it. All right, add 12. 3x is less than 15. We're going to divide, and we're going to say x is less than 5. Number line, we find 5 on our number line. We're going to go open circle because it's not equal to, and x is less than, so we're going to shade to the left of that number. All right, next one. Now let's clean this up first. 6 plus 10 minus 5x. We're distributing the 5. It's less than or equal to 41. I'm going to combine these together and say 16 minus 5x. Less than or equal to 41. Let's subtract 16. Negative 5x is less than or equal to 25. And our last step, we're going to divide by that negative. X, negative 5. But remember, when we divide by a negative, we're going to switch our inequality. So now we're greater than. Number line, negative 5, closed circle. And on On this one, x is greater than, so we're going to shade to the right. Okay? All right. So if you followed along on that one, you should be able to do the understanding check. Try that on your worksheet. All right, example 2. Sometimes you're going to do everything right, but there's either going to be no solutions or all solutions, meaning it doesn't matter which number you pick, that's going to work for an answer. So let's look at 2 examples here. I'm going to clean up our parentheses first. 2x minus 3 is greater than 2x minus 10. Let's start by subtracting 2x. Well, that cancels out both sides. All of a sudden, negative 3 is greater than negative 10. And so we need to ask ourselves, is that true? On the number line, is negative 3 bigger than negative 10? And yes, it is. It's always going to be bigger than negative 10. There's never a situation where negative 3 is smaller than negative 10. So this is all solutions. No matter what number you put in up here for x, it's just going to cancel itself out and it's going to work. All right, so every single number works. I'll bet you B says no solution. Let's find out here. 7x plus 6 is less than 7x minus 28 when we distribute. We subtract our 7x, and we've got 6 less than negative 28. Is there ever a situation where 6 is smaller than negative 28? Nope, that can never happen. So our answer is there are no solutions that make this inequality work. All right? So the key here is if your variables cancel each other out, it's either all or no solutions. See if you can figure out which one for your understanding check. All right, let's try a word problem here. The band at the left, and there was a picture that I didn't copy, agrees to play for $200 plus 25% of the ticket sales. Find how many ticket sales we need for the band to receive at least $500. All right, so we talked about this before. We've got our fixed cost and our variable cost. 200 plus 25%. I'm going to write this as a decimal. 0.25 of. All right, so this of is a really key word when we're doing word problems. That's going to mean multiply. So 0.25 times the ticket sales. So I'm going to use T for tickets. All right, and the money that we make, we want at least $500. So 500 is over here. And let's think to ourselves, okay, least, does that mean greater than or less than? So we want at least, so we want to be bigger than 500. Would it be okay if we made it exactly 500? And at least, yeah, it would. So we can have an equals in there as well. All right? So now that we have it set up, let's go ahead and solve this. First we'll subtract the 200. And we've got 0.25t greater than or equal to 300. And I'm going to change this 0.25 into a fraction. Okay, this is a situation where fractions are actually going to really help us here. Remember, 25 cents is a quarter of a dollar. And it's going to help us because I might not know how to divide by 0.25, but I know how to divide and get rid of that 4. Instead of dividing by 4, we're going to times both sides by 4. And those will cancel, and we've got t is greater than or equal to 1,200. All right, so to make 500 bucks, there needs to be 1,200 people showing up to the show. More than 1,200 people show up, we're going to make even more money. See if you can figure out what to do on your understanding check. All right, so far we've done just single inequalities. Now we're going to do compound inequalities. And what a compound inequality is, it's a pair of inequalities, 2 of them, and we're going to join them either by the words and or with the word or. All right? And so here's a couple examples. -1 is less than x, and x is smaller than or equal to 3. So really what we're saying here is that -1 has to be, x has to be in between those two numbers. Right? X has to be bigger than -1, smaller than 3. The other one's saying x is less than 1 or bigger than or equal to 3. All right, and so let's take a look at what these would look like. This or, here's -1, here's 3. The or, I would be less than shading to the left. And the right one here, I'm bigger than the 3 going outside this way, right? So outside. Or is outside, usually. So that's a kind of a way you can remember it. O matches up with outside. This one here, I'm in between -1 and 3. Right? I'm in between the two of them. So and I'm going to shift in between the two of them. All right? So to solve this, we're going to find all the variables that make the inequalities true. All right? So let's take a look here. I've got an and compound inequality. Let's go ahead and solve it like we normally would, but just two different problems. So I'm going to solve the left one first. I'll add 1. 3x is greater than -27. Divide by 3. X is greater than -9. Let's solve this other one. -7 minus 7. 2x is less than 11. Is that right? Oh, 12, sorry. And we'll divide by 2. X is less than 6. All right, so we're bigger than -9 and smaller than 6. So let's get a number line here. I'm going to put -9. Open circle. I'm going to put 6. Also open circle. And I want to be bigger than -9, and smaller than 6. That's an in-between. Here we go. We're shading in between the two of them. Right? I'm smaller than 6, so I'm going that way. I'm bigger than -9. Everything in between. See if you can get your and inequality to work on your understanding check. All right, let's try the or one. So same thing, I'm going to solve these. Add 2, 4y is greater than or equal to 16, so y is greater than or equal to 4. Add 4, 3y is less than or equal to -9, so y is less than or equal to -3. This is an or. So we're going to get ourselves a number line. 4, closed circle here, and -3, which is to the left, closed circle on this one. And now or, we're going to the outside. I want to be bigger than 4. Right? Bigger than 4 going that way. I want to be less than 3. So we would shade to the left. All right? So, or we're going on the outside. Try your understanding check. All right, last one here. The plans for a gear assembly specify. Oh, I think there might be one more. Is that true? Nope, this is the last one. Okay. The plans for a gear assembly specify a length of 13.48 centimeters with a tolerance of 0.03 centimeters. A machinist finds that the part is now 13.6 centimeters long. By how much should the machinist decrease the length? Okay, so let's look at this word tolerance. Okay. So tolerance is how much air is okay. So this thing should be 13.4 centimeters long. That's perfect. But we say we can go up and down just a little bit, right? We can be a little bit smaller by 0.03. We can be a little bit bigger by 0.03, and those are still acceptable. So we want to figure out, okay, what's the biggest and smallest that we could be? So let's subtract 0.03 first, and we get 13.45. And then if we add, we end up with 13.51. So now we have a range. We're saying, okay, 13.48 is perfect, but we're allowed to go as low as 13.45 and as high as 13.51. All right? So now we know the highest end. And we've got this piece that's 13.67 centimeters long. Well, we need to get it down to our maximum allowable length, which is 13.51. So let's figure out how much we would have to chop off of that to get it right. Turns out that we're 16.16 centimeters too big. All right? So we're looking at tolerance, a range of values. All right, try yours on example 6. And if you have any questions, come find me or ask me in class. Good luck.